Please get started on the do now. Hello, Ria Betswe. Who else is here? Anam, hello. That's a nice message, Cece. Thank you. Thanks. Hi, Zayon. Nice message. Thank you. Okay, so get started on the do now, please, grade 10s. And as soon as everybody's here, then we will get underway with our lesson again. Marisa, you're here. Good. Intlapazzo, how's it going? Nice to see you again. Thank you for joining us. So yeah, guys, you know the deal by now. Get started on the do now, and then we'll get underway with our lesson as soon as everybody's here. Oh, and Naileti, you've joined us. Welcome back. It's so nice to have you again. If I've not said hello, I hope I've said hello to everybody. Okay, so grade 10s, I hope you've got a book with you. Maybe you've got the same book that you're using all the time is probably a good idea. And that you've got a pen and a calculator, because we're definitely going to need those calculators tonight. And then yeah, just get started on the do now, and then we'll talk about the answers in a second, and then we'll get underway with our lesson. Hi, Nawazi. Thanks for your message. Sorry, did I not say hello to you? My apologies. I'm sorry. Hi, David. Thanks for your message. Cool. I think just about everybody's here. Hi, Jatuka. Nice to see you again. I'm so glad you joined us. Okay, so I'm going to give you guys another minute just to finish whatever question you're on, and then we're going to start talking about these do nows and then get underway. Okay, well, hopefully I've given you guys enough time. I don't mean to rush you, but I obviously want us to get started on our lesson. So we're going to be talking about sketching the exponential function today. But before we can talk about sketching the exponential function, is obviously a few things that we need to go through and make sure that we know in order to be able to answer these questions. But we'll talk about that in just a minute. David, if I may, what did you get as your answer for the first one? If you would be so kind as to either type it in the chat or you can unmute your mic and share your answer with us, if I may ask. Thank you. You're still working on it. Okay, David, no stress. Anybody else that finished the first question and wants to give it a shot? Me, cool, Zayon, go for it. Either you can type it or you can unmute your mic, up to you. Okay, so Zion says 84 y squared. Okay, Cecily, you've also put your answer in there. That's great. Minus 150. Okay, so that's really cool. So both of you have got the first two terms the same, but Zayon, you're saying plus 14 at the end, and Cecily is saying plus 33. Okay, I can understand why. All right. So now, Zayon, with pleasure, Rabin, with absolute pleasure. I would love you to. You did. There you go. You see, you even figured it out before I even told you. Brilliant. Well done, Zayon. Excellent. Excellent. And you know what, Zayon? That's a really common mistake. There are so many people when we're starting to do FOIL, we multiply, and then we add or subtract or whatever it is. So quite right. Okay, you guys are amazing. Look at that. You see what a little bit of practice does. I'm so happy. Well done. Excellent. Okay. Rabin, you wanted to do the next one. It's all yours.
Ma'am, it's g squared minus 10g plus 25.
Oh, you are so brilliant. Perfect. I got exactly the same answer. Thanks, Rabin. That's perfect. Okay, good stuff. Well done. Grade 10s, these are really important questions. I know they're little starter questions for us, but, you know, being able to do these sorts of things really important for us later on and in all places in maths. So it's a good thing that we've practiced that. Well done. I'm really impressed. That's great. Okay, so let's move on and let's start talking about the exponential function. So first of all, I need to ask you guys a question. Okay, first question number one. You can just pop this into the chat for me. Have you done, not the exponential function, have you done exponents at school? So if you can just send me an answer to that. Not the exponential function, have you done exponents? Yes, cool, thank you. Thanks, C. Claire. Yep. Oh, brilliant.
Yes, ma'am.
Thank you. Nazol. Oh, good. I'm so glad you're with us again, Nazol. Karabo, thank you. Okay, so you've all done exponents. Have you done the exponential function? Okay, so that's the second question. So you can just pop it in the chat again or unmute your mic. I don't mind. Okay, thanks, Marisa. Okay, Zayon. Nolwazi, no. Flumela. Hello, Flumela. Inem, hello. You've done it. Okay, all right. Well, I appreciate your responses. Thank you very much. Okay, so if you've done exponents, that's a really big thing, okay? Because before you can do the exponential function, your teacher would have had to teach you exponents, because you need those skills to be able to do the exponential function. That's fine, Nileti, no worries. Hopefully after this lesson, you'll understand how to sketch it a little bit better. right? So the reason why I asked is just because I wanted to know where you were at in terms of your schooling and whether you'd seen these things before. So for those of you that haven't done the exponential function, this is going to be new, but you should, considering that you've done functions and you've done exponents, you should be able to understand what we're talking about. All right, so now, when we are talking about the general equation of an exponential function, it looks like this. Now, when we get into grade 11, they add a couple more letters, but I don't want you to stress about that, but it looks like this, okay? So y equals b to the x plus q, all right? As always, x and y, what do they represent for us? They always have to be, someone can tell me or pop it in the chat, they always have to be yes, they do have to be numbers, correct, but they have to be inputs and outputs. They have to be x coordinates and corresponding y coordinates. Okay, so this is always an x coordinate and its corresponding y coordinate. Okay, and we need to know that so that we sub appropriately into our formula. Those of you that have done the exponential function, can someone tell me what the letter B stands for? So you can either beta, hi Phoebe. In this case, I'm afraid that's not correct, Phoebe, but that's a good try. It's actually a little bit easier than that. Anybody know what the letter B is there to represent? No? Okay, so when it comes to exponents, all right, the letter B is there to represent binomial. Good shot, Tabasing, but unfortunately in this case it's not, but well done. All right, it's there to represent a base. There we go, Phoebe, you got it. Perfect. Perfect, it's supposed to be a base. So when we talk about exponents and bases, we need to know what we mean. So what I'm going to do is I'm just going to move the board over to the side and I'm just going to make sure that we're okay with that idea, okay? So as far as a base is concerned, a base is a number like 3 and it's written to a power. Okay, so what we would typically say is that this number over here, that is called the base. And this number over here is called the, can anybody tell me? You can type it or pop it in the chat or unmute your mic. What do I call? Say again, my love.
Exponent.
Perfect. Okay, so that's the exponent. Quite right, Marisa, that's the exponent. And what does the exponent do? What's the purpose of the exponent? What's the exponent's job?
You times the base number by the exponents.
Okay, so are you saying that this means, does this mean 3 times 2? Is that correct? No.
3
Okay.
times 3.
3 times 3, quite right. Okay, so it doesn't mean 3 times 2. I wrote the wrong thing there. And that's something that we always, well, sometimes we do make mistakes with that. So the exponent is there to tell us how many times we need to multiply the base with itself. So it means 3 times 3. Just like in our starter activity, we had a square, so we multiplied the bracket by itself. All right, so what's important is that we know what a base is and we know what an exponent is. All right, so the base is the number with the exponent. All right, let's go back and let's have a look at the next thing. Right, again here, grade 10s, we see the letter Q. Can anybody remember what the letter Q represented in the hyperbola?
Turning point.
That's correct for the parabola. It is the turning point for the parabola and also the y-intercept.
Asymptote.
The asymptote. Who said that?
No, Wazi, ma'am.
No, Wazi, you are amazing. Thank you so much. Okay, so this is also an asymptote. Okay, so an asymptote is a line that the graph can't touch. Now, some of you who haven't done the exponential function, you wouldn't know that. Okay, so what I've done here is I've given you the formula in its general form, and then I've written a couple of examples underneath. Okay, so in this first question, the one that I'm writing number 1 next to, what number is the base? So you can either unmute your mic or you can pop it into the chat. What number is the base?
2.
2, correct. 2 is the base. All right. In this particular case, our exponent, well done, Karaba, that's quite right. And in this particular case, in number 1, what's the value of Q? What am I trying to imply the value of Q is? Perfect.
3.
100%, you're both correct. Okay, so the value of Q is positive 3, all right? In the second example over here, what am I suggesting is, well, not suggesting, I'm telling you, what am I saying that the value of the base is? In number 2, what's the, good, a half, quite right. And what's the value of Q?
Negative 3.
Beautiful, you're all correct, lovely. Okay, so you can see where the B fits in and where the Q fits in, all right? We're going to talk a little bit now about how we would go from the 2 to the half and back again. But before I do that, I just wanted to check 2 things as far as exponent laws are concerned. Okay, so, and it relates to what we've just spoken about now with the 2 and the half. All right, so the first thing that I would like to ask you guys is, what happens if I have a base of 2 and I raise it to a power of 0?
Then the answer will be 1.
The answer will be 1. Quite right. The answer will be 1. And what would happen? I mean, if I had another letter, for example, like if I had an X and I raised it to the power of 0, would that still be 1? Quite right, Sihle. Yep. Anything to the, quite right, guys. Okay, so anything, whether it's a letter or whether it's a number, if I raise it to the power of 0, I end up with 1. So that's really important. We're going to use this now, okay? The other thing that I just want to check before we move on is what happens with negative exponents. Okay, now I know that when we start talking about negative exponents, people start to get a little bit worried. So now what I'm going to do is I'm going to write 2 to the power of -1. What's the answer to that?
A half. 1/2.
Absolutely, it's a half. So in other words, what I'm doing, good, well done. So in other words, what I'm doing is I'm rewriting the base with the reciprocal. So in other words, 2 to the -1 means 2 to the -1 over 1. So that invisible 1 that was at the bottom is now at the top. And then what I've done is I've rewritten the base in the denominator and I've changed the sign of the exponent. Okay, so now if I write 2 to the power of -2, what's that equal to? Again, you can pop it in the chat or you can unmute your mic. Good, see here. Sorry, what did you say?
I got 1/4, ma'am.
That's right, correct. Okay, so what I want you to realize, 100%, I mean, we can obviously work these things out on our calculator, but what I want you to realize is this, okay? So numbers work in patterns so much of the time. So you guys told me 2 to the power of 0 was equal to 1. And you know that 2 to the power of 1 is equal to 2. And you also know that 2 to the power of 2 is equal to 4. And I'm going to do one more, 2 to the power of 3, and that's equal to 8, because it means 2 times 2 times 2. So now when I write 2 to the power of minus 1, I get 1 over 2. Okay, when I write 2 to the power of minus 2, I get 1 over 4. When I write 2 to the power of minus 3, then I end up with 1 over 8. Can you see the pattern? Okay, so you never ever have to feel intimidated or scared when it comes to negative exponents, because it's just like the positive one, except that it's the base is now at the bottom. Okay, so in other words, it's now 2 to the power of positive 3 at the bottom, or 2 to the power of positive 2 at the bottom, or 2 to the power of positive 1 at the bottom. Okay, so I think once you see that, things also just kind of help to fall into place. All right, so now let's go back to where we were and let's talk about how we're going to apply all of this. I'm going to come back to that bit now. I first want to go here. Okay, so this lesson was supposed to be, or is supposed to be, about sketching the exponential function. So when we sketch functions, again, the sort of things that we're going to be marked on. The shape of our function. Okay, that's important for us. Okay, we need to speak about or label or sketch the asymptote. We also need to calculate and label the y-intercept. And then we also need to calculate and label the x-intercept if it exists. Okay, so now in grade 10, you do end up moving the graphs up and down. So it is possible for there to be an x-intercept, but not always. All right, so it just depends on whether the graph has been shifted or not. So I'm going to go down now to this graph over here, and we're going to talk about sketching that. Okay, so this is the graph of 3 to the x, g of x equals 3 to the x minus 3. We want to sketch g on a set of axes, clearly showing all intercepts with axes and asymptotes. All right, now something that we haven't discussed yet, but I'm going to talk about it now, is how do we know what shape our exponential function is supposed to be? Does anybody know from school how we would? No? Okay, no stress. All right. So exponential functions, that's a set of x and y axes, can either be like that. You're not doing this at school. That's fine, Ketlejo, not to worry. Even if you haven't done this at school, you're going to do it at some stage, and you should be able to follow along. So either an exponential function looks like that. So in other words, it's growing exponentially. Or sometimes exponential functions can look like that. They're always curved, quite right, Sihle. Now, mine are not that great. I haven't drawn them very well. I'm sure at home you're drawing yours much better than me, but you're right. They're always curved like that. So see here, if I'm now going to draw this graph, 3 to the x minus 3, how do I know whether I'm drawing option number 1 or whether I'm drawing option number 2? And that comes down to the value of the base. Okay, so in a situation like this, where both of these have been sketched above the asymptote, and we'll talk about that now, in a graph that is shaped, I like to call this one over here, number 1, I like to call this one J-shaped. Can you see the J over there? And then this one over here, I like to call this one C-shaped, but those are just names that I give to them. So a J-shaped exponential function is always going to have a base, B, that is bigger than 1. A C-shaped graph like this one is always going to have a base that is between 0 and 1. What's really important for us here, grade 10s, is that B can never ever be 1. B can never, ever equal 1. Do you know why that is? Why can B never be 1? If we think about it.
Because 1 multiplied by itself is always 1.
Good, perfect, well done, that's excellent. Okay, so that's why B can never be equal to 1, all right? Because it doesn't matter what power we put, what exponent we put on 1, as you perfectly said, it's always going to be equal to 1. In this situation over here, B is between 0 and 1, so it's a fraction. So in other words, it could be something like a half, or a third, or a quarter, or something like that. And then it results in this C shape. And we're going to talk, I'm not going to talk about it now, but we're going to talk about why that happens, right? So first of all, let's just go back to our graph that we said we were going to sketch. And now let's have a look. The base in this case, unfortunately, the asymptote is more or less the same thing, but the base in this case is the number 3, the one that I'm putting the little pink line underneath. Okay, so B is equal to 3. And that means that this graph has to be J-shaped like that. Okay, so you've got to look at the value of the base, right? Now, the asymptote, right? So Q represents the asymptote. So that means that the line, let's just get a different color here. The line that represents the asymptote is the line y equals minus 3. Okay, so that is the line that the function cannot go through. All right, so this function cannot produce any numbers that are either equal to minus 3 or smaller than minus 3. Okay, it's not possible for us to do that. How do we find X and Y-intercepts? Well, we find X and Y-intercepts in the same way for all functions. If you recall that we find the Y-intercept by letting what be equal to 0? Can someone tell me?
X be equal to 0.
X equal to 0.
Excellent. Well done. X be equal to 0. Beautiful. So I'm going to write g of x. G of x is y. Okay. 3 to the power of 0 minus 3. And you all told me that you knew what anything to the power of 0 was, which makes all of this so much easier. So if I've got 3 to the power of 0 minus 3, what am I going to end up with as an answer?
1.
Almost. Not quite. Yeah, 3 to the power of 0 is 1, and then 1 minus 3.
Negative 2.
Beautiful. That's it. Well done. Sorry, I stopped thinking there for a second. 100%. So is everybody confident about where the negative 2 came from? From 1 minus 3.
Yes, ma'am.
Okay, cool beans. All right. Now, how do we find the x-intercept?
By letting
Y
equal to 0.
Beautiful. By letting y be equal to 0. Well done. Okay. So now, and we have to write that grade 10s. We have to write, that's quite right, Daniel, make y equal to 0. So we have to write 0 equals 3 to the x minus 3, because there's always going to be a method mark for that 3 over there, and then a mark for that one over there, and a mark for that. Okay, and now what are we going to do with this minus 3 that's on the right-hand side? What am I going to do with this minus 3 here? Can it stay there?
You're going to take it to the other side to make it positive 3.
Beautiful. Wow, you guys are amazing. You don't even need me to teach you. You know all of this. It's wonderful. Well done. So positive 3 is equal to 3 to the x. Ha ha. And now what do we do? Good. Yes, Daniel. We take it over and it becomes positive.
We divide by
both
3.
sides by 3. Ma'am, don't we divide both sides by 3?
Okay. I can understand why you are saying we should divide both sides by 3. But let's just have another little chat. Just quickly. There's so much to know with the exponential function before we can actually start teaching it. Okay. I wanted to show you something over here, right? there we go. Daniel, quite right. 3 to the power of 1. Excellent, excellent. Okay, so Daniel, just give us 2 seconds. I just want to explain to the others what's going on, okay? So grade 10s, if I write something like this, if I write 2 to the power of 3 equals 2 to the power of x, okay? I cannot divide by 2 because 2 is not like 2x over here. It doesn't mean 2 times x. This is 2 to the power of x. So if it's 2x equals 8, then I can say divide by 2, divide by 2. But here we're working with powers. Okay, so remember, our 3 is an exponent. Our x is an exponent. So the idea behind this, grade 10s, is that you want to make the bases the same. Okay, so if you can write this as 2 to the power of something and that's as 2 to the power of something, after we make the bases the same, we can then say, well, x has to be equal to 3. We can do one more example. Let's say I've got, no, let's do something else. Let's talk about 5 to the power of 2. Okay, so actually, I'm being silly. If I say 25 equals 5 to the power of x, this is an instruction to me to write 25 using base 5. So I can rewrite 25 as 5 to the power of 2. There we go, Sihle, quite right. And now, what would the value of x? So yes, it would, Phoebe, quite right. Quite right. That's exactly the point I was trying to make. Good. Okay, so let's go back to where we were. Okay. The whole point of this was over there. Right. So I don't know if the rest of you can see what Phoebe popped in the chat, but that was absolutely perfect. So for the rest of you, remember, if we write a base, it has a little invisible exponent of 1. All right, and now that we've made the bases the same, we can then conclude that x must be equal to 1. Okay, how does that feel? Does that feel good? Thumbs up, thumbs down? You can pop something in the chat. Good, thank you, Sihle. Marisa, good. Sayon, thank you. If you don't understand, I don't mind explaining again. Good stuff. Okay, so now we have to draw this. Okay, we have to sketch this graph. We have already decided that it's going to be J-shaped. Okay, its asymptote is y equals -3. Okay, Nazal, we'll go through this. We'll go through this again. We're just going to let the others try a question, and then we will go through this again. No problem. Okay, the first thing that we want to do when we are sketching graphs that have asymptotes is we want to draw and label the asymptote. So that's what this dashed line here is for. So you have to label this line. It's the line y equals -3. If you don't write y equals -3 over here, then you've got to at least write -3 over there as well, okay, in order to label it. So that's one of the expectations. Let me just get rid of the thing over here. I always do this. I always label it as the line y equals -3. Now we want to have a look at drawing our graph. Your screen is blank. Okay, Inam, I'm sure Tula will try and help you with that now. I don't know why. So our x-intercept takes place to the right-hand side of the y-axis. So this is our y-axis over here, and this is our x-axis. So x is equal to 1 has to be either here or there or somewhere on the right-hand side of the y-axis. Y is equal to -2. So that has to be somewhere down here. So if that's equal to -1 over there, roundabout, then -2 would be somewhere over here, right? So our graph is going to be J-shaped, and it's going to look something like that. Here is my x-intercept, which I must label as 1 and 0. And here is my y-intercept, which I must label as 0 and -2. When you draw a exponential function, just like with all the others, you are going to be marked on these three things. Okay, so the first thing that they will mark you on is the shape. The second thing that you'll be marked on is your X and or Y-intercepts. And then the last thing that they will give you a mark for is for the asymptote. Okay, so those are the three things that your teachers are going to be looking for. Okay, grade 10s. So the shape, the correct coordinates at the X and Y-intercepts, and then they're also going to be looking for the asymptote. Okay, everybody happy with that?
Yes, ma'am.
Okay. What I'm thinking, I know there's some people that seem to be doing really well with this, and I don't want to hold them up, but I also want to help the people that didn't understand. Do you think that it would be okay if if I showed you this question over here and you went ahead and started trying to answer it, and then I could just explain a little bit to other people? Would that work for everybody? Oh, great, guys. Thank you so much for being so understanding. So I'm going to leave that there, and then the other people that didn't understand, then I can explain just a little bit more, and then we can talk about this question. So Phoebe and Daniel and everybody else has just responded to me. You get on with drawing this particular graph, all right? And then hopefully by the time you finish, everybody else will be in the same place as you. Okay, if you're stuck on anything, unmute your mic, put a message into the chat and just ask me, okay? So don't feel like you can't do that, because you really can, okay? All right, so now the other people that were a little bit confused and didn't understand what to do, where is it that I lost you? If you can just pop a message into the chat for me. Where did I lose you? What did you not understand that I had done? So Katlejo and Nazol, where did I lose you guys? Okay. Okay, Nazol, I'm going to answer your question right now. Inam, sure, Luke. Okay, so there's two questions that I need to answer. So yes, what Nazol said. All right, that's fine. That's not a problem. Let me just see if it's possible. I'm not sure if I'm going to manage with I wish it was really nice if we could have bigger screens, isn't it? So no, that doesn't really help you. Where was no, there's the calculations over there. Does that help if I move it down like that? I'm just going to move it over to the side. Let me just go down here. Okay, so, all right, so that helps. Okay, so now there's a couple of questions that I just want to answer. Okay, so first of all, the first person who asked was Nazol, and you said to me, how come 3 equals 3x? Okay, so what you've got to remember here, all right, is that if I write the number 3, that means 3 to the power of 1. Okay, if I write any number, in any number that you can possibly imagine, I mean, we're talking about positive numbers now, but if I write 2, I mean 2 to the power of 1. Okay, so if I've got an equation where 2 to the power of 1 is equal to 2 to the power of x, the idea is that because you've made the bases the same, Okay, so this base and this base are the same. Because you've made them the same, it's okay to say that the exponents have to be the same as well. So they call it equating the bases and equating the exponents. Does that make sense? So when I took that 3, that minus 3 over to the other side, it became positive 3 to the power of 1. Okay, if I wanted to, if I needed to solve, let's say you had a function that was y equals 3 to the x minus 9. And now you wanted to work out the x-intercept. Nizol, you'd make y equal to 0. You've now got 3 to the x minus 9. You're going to take the minus 9 over to the other side, and it's going to become positive 9. Now, what can you do with 9? How can you write 9 as 3 to the power of something? Nizol Katlego, do you know how to do that? Yes, Harrison, you can screenshot, no problem.
Ma'am, is it 3 to the power of 2?
It is, it's beautiful, perfect, 100%, 100%, 100%, exactly. So you're going to write this over here. Where's my pen gone? Okay, so 3 to the power of 2, brilliant, equals 3 to the power of x. So now what's x equal to? Yes, Nizol, 3 squared, perfect. X would be equal to?
2.
Beautiful. Well done, you got it. Okay, does that make a little bit more sense now? I hope so. Okay, so Nizol, I've answered your question. Inam, I'm trying to show you what we had done on the other side. Luke, okay, your question was, could you please explain what the asymptote is like and what its purpose is? Yes, with pleasure. What I'm going to do, Luke, is I'm just going to clear the space that I was writing in over here, just so that everybody can continue to see the question. And then I can answer what it was that you were asking me. Okay, so some functions have asymptotes and other functions don't. And the functions that have asymptotes that you are going to be studying, so there's also a trig function that has an asymptote, but you'll do that once you've done trig. So the general functions that have asymptotes that you study are the hyperbola and the exponential function. Okay, so what happens is that there are places on the Cartesian plane where our curves cannot go, right? The mathematical word for that is we say that it's undefined at a certain value, okay? So what we would find, like with the function that we were just talking about, y equals 3 to the x minus 3, right, is that our asymptote is existing at the number -3, right? So our function does not have the ability to be able to go through this particular value, all right? So it would be undefined at -3. And that's what results in this J-shaped curve, because whilst it continues to go in this direction over here where I'm drawing the arrow and the y numbers get bigger and bigger and bigger, what happens, can you see how the graph comes down and then it starts to curve and it becomes closer and closer and closer and closer and closer and closer to the number -3, but it never ever gets there, all right? Now, what is the reason for this? Why is this happening, Luke? Okay, so the reason for it is because if I have 3 to the power of x, all right, I can never, ever get -3. It's not possible for me to get -3 as an answer. It doesn't matter what I make x equal to, even if you could imagine the tiniest number, because, and this is what comes back to our negative exponents, if I've got 3 to the power of -1, that's going to give me 1/3. If I've got 3 to the power of -2, that's going to give me 1/9. If I had 3 to the power of, gosh, I can't even imagine how tiny this must be, but 3 to the power of -1,000, it's still going to be a positive number. Okay, so it's just going to be a tiny little fraction. Okay, so that's why these graphs have asymptotes, right? Because it's not possible to generate a certain value. And then hyperbolas have them and exponential functions have them. I hope, Luke, that I have explained what that is and that you're okay with that. Ria Betsway, you were saying how to correctly form a shape. Okay, Katlejo, you still don't understand. All right, give me 1 second. Ria Betsway, you were talking about shape, so I'll just go through that again quickly. So there's a little bit more to this than what I'm actually discussing with you today, but our time is so limited that I unfortunately can't go through everything. Right. So what we've done today, Ria Betsway, is that we have only looked at exponential functions that are sketched above their asymptotes. Okay, so that's what we've concentrated on today. It is possible to also draw an exponential function that's drawn below the asymptote, right? But I haven't spoken about those today. So when we are talking about drawing above the asymptote, we can only get one of two shapes. Either we get a J-shaped curve that looks like that, in which case our base number has to be a number that is bigger than 1. Or, I didn't get a chance to even explain this to you guys, I can have a C-shaped curve where my base is a number between 0 and 1. Okay, so for example, I could say that this function that I've drawn over here, that could be the function y equals 2 to the x. But this function over here, this is the function y equals 1/2 to the x. Now, how did we go from having a base of 2 to having a base of 1/2? The answer lies in negative exponents. If I have, I'll just rub this out and I'll just show you this quickly. All right. If I have, I'm going to try and draw a Cartesian plane here just very quickly. Always so badly. My lines are terrible. Sorry, grade 10s. Okay. So what I'm going to do is I'm going to sketch the function of y equals 2 to the x. And then let's use a different color. Let's go with purple. Now, you're going to have to forgive me for my shape, all right? I'm trying to draw a mirror image, right? I'm going to draw a function that looks like that, okay? This purple line is supposed to be a mirror image of the orange one, all right? What happens when I reflect something over the y-axis? From one side of the y-axis to the other side of the y-axis, x changes sign, because remember, on this side over here, x is all positive numbers. On this side over here, x is all negative numbers. So if I start with the orange line and I want to create the purple one, I have reflected the orange line over the y-axis. This gives me y is equal to 2 to the minus x. Now, if you recall, we are not allowed to write that with a negative exponent. We're expected in grades 10 and 11 to always write things with positive exponents. So if I've got y equals 2 to the minus x, what I can do is I can write it as 1 over positive 2 and then change the sign of the exponent to a positive. Okay, so that's how you know the shape, Ria Betswe. All right. So a graph that has b greater than 1 will be J-shaped if it's drawn above the asymptote. And a graph that has b between 0 and 1, a fraction, is going to be a C-shaped function. I hope that explains things to you well enough. Let's see if there's anybody else who had another question. Have I answered everybody's questions? I've tried to sort of be thorough and make sure that I have. Is there anything that anybody still doesn't understand or wants me to explain again? Okay, so none of you have said yes or no, so I'm taking that as we're all okay. Is there anybody who has completely finished? Nope. Okay, Phoebe, that's great. Thank you. Is there anybody who's finished question 6? Okay, Erickson, say on. Marisa, lovely. Daniel as well. Okay, NM, you're doing 6.3 now. Cool beans. Okay, so we've got 9 minutes left. So I'd obviously like to mark this with you. Some of you that are obviously listening to me, can you move 6.3 up? I certainly can do. Let me just move over and up. And we can make it bigger. There we go. All right. Now, my apologies, but I'm obviously trying to answer questions with some people and then let other people carry on with the work. I mean, I'm trying to, but I couldn't see that last question. Sorry, Daniel. Sorry. So 6.3, no problem, Sihle, pleasure. I'm sorry that it disappeared off the screen. Anyway, I want you to try and see if you can do that, but we're going to go through the answers now because we haven't got a lot of time left. All right. So first things first, consider the function g of x equals 2 to the x minus 2 and answer the questions which follow. In 6.1, determine the coordinates of the y-intercept, and that was out of 2 marks. So this is a typical sort of exam question. Would anybody who's managed to do this like to tell me what did you get for that question? What did you get for 6.1? So you can either unmute your mic, say on got -1, cool.
-1.
-1, thank
-1.
you. Lovely.
0 minus 1.
-1.
Indeed, perfect. Okay, so you're all 100% correct on that. I did the answers over here, and I also got -1 as my answer. All right, so there would be 1 mark for subbing in the 0, and there would be another mark for the -1. Okay, so the coordinates 0 and -1 is perfect. Okay, then the next question said, determine the equation of the horizontal asymptote. Who's going to do that question for us? Good stuff, say on.
-2.
Indeed. Indeed. What would happen, do you think, in this question if you just wrote -2? Do you think that the teacher would give you all the marks? Nope. Why not, say on? What's missing? There we go, Harrickson, you've done it. Okay, it has to be y equals -2. Okay, because they have asked you for the equation of the horizontal asymptote. So remember grade 10s, although it's something we haven't spoken about, but it is something that you should have done in school. All horizontal lines take the form y equals. So quite right. Okay, Harrickson, if they ask you for the equation of the horizontal asymptote, you should write the line y equals -2. Okay, perfect, good stuff. Let's have a look at the last question. All right, so here they wanted us to, on a set of axes provided, okay, I didn't provide you with one, draw a neat sketch of G, clearly indicating any intercepts with the axes and the asymptote. And this was out of 3 marks. Okay, so this is what I was talking about a little bit earlier. All right, so what piece of information is missing that we need in order to be able to draw this graph?
The X intercept, ma'am.
The X intercept, quite right. Okay, it would be a J-shaped graph, quite right. It would be a J-shaped graph, say on. Good. So you know what shape it is. It's got to be J-shaped, right? We know that we've got the Y-intercept. We've got the horizontal asymptote. We need to work out what the X intercept is. So what did you guys get as the X intercept?
I got X equals to 1.
X equals to 1. Okay, good. Thank you. Zayon, you also got 1. What did everybody else get? Also got 1? Okay, me too. Right, so the little bit of working that I've showed here, grade 10s, is super important. Okay, when you are working with exponents, you have to show this step. I'm going to just put a little tick next to it. So where is it? There we go. So this step over here is very, very important. Yes, see, Claire, that's exactly the right one. Okay, so 2 to the 1 equals 2 to the x, and then you can conclude that x is equal to 1. So this very, very, very important. It must be shown. All right, and then drawing the graph. Okay, remember the first thing that we need to draw is the asymptote. Always draw, if a graph has an asymptote, we always draw the asymptote first. Okay, so generally as a dashed line, just like that. There it is, the line y equals -2, and then we're going to label the x and y intercepts. Okay, 0 and -1, 1 and 0, and that's where those 3 marks would be allocated. Okay, so now what I want to know is, how did that go? And do you have any questions? You can pop something into the chat. Did that go okay? Is there anybody that got 6 out of 6? Good. Thank you, Harrison. Thanks, Ayan. Is it a bit better, Nazol? Okay. Good stuff. You sure, Marisa? Okay, Anna. Okay, because I know some of you haven't done this at school. Those of you that hadn't done the exponential function at school yet, how did you feel about that? Oh, good, you got 6 out of 6. Excellent. Did it make sense if you've done other functions? Thanks, Marisa. Okay, so okay, thanks, Karabo, perfect. I hope so. Thanks, Sihle. I'm glad, Phoebe. All right, so what I want to do just before we go, because we've got 2 minutes left, I'm just going to scoot over to the side over here, and I just want to summarize very quickly the things that we've spoken about. Okay, so do you recall that the first function we spoke about was the quadratic function? That was the line y equals ax squared plus q. Right, so we know that a line is a parabola, or a function is a parabola, should I rather say, when we've got a square in it. Okay, so to the power of 2. What's a little bit confusing for us, right, is this over here, the q. Okay, this is the y-intercept, and in grade 10, it's also going to be the turning point of the function. Last week, I know, Katlejo, I feel the same thing. I wish it could also be 3 hours. I really enjoy my time that I spend with you guys. I so look forward to these lessons. Okay, so that was the parabola, right? Parabola. Okay, and then we did the hyperbola. And if you guys can recall, that was the line y equals a over x plus q. Only now the q means something different here, grade 10s. The q is not a y-intercept or a TP. The q is the asymptote. Okay, so you've got to remember the difference. And then just very quickly, because I know our time is up, today we spoke about the exponential function. This is the line y equals base to the x plus q. And just like the hyperbola, this plus q over here is an asymptote. Okay, so we know, I know in math, I think this is where maths needs to say sorry to people, because here we've used a q and it represents the y-intercept, and here we're using a q and it means something different. So you've got to remember, when it comes to the hyperbola and the exponential function, q is the asymptote. Okay. Anyway, I just wanted to point that out to you again, and I will see you all next week on Tuesday. Okay. All right, guys.
Oh no, you can continue. Goodbyes.
No, I'm done. I'm done. Thank you. Sorry.
Okay, awesome. Hi everyone. I'm just gonna quickly power through these quick slides as usual, because we don't really have much time left. So we are still on functions and graphs, obviously, and we already finished with our 6th lesson, which is awesome. Time really does fly. We're only left with 2 lessons for this series. So just lessons 7 and 8, and we'll still be continuing with exponents. So yeah, this has really been awesome. And it's been the same names since the beginning. It's still the same people. So you guys have really been great. And consistency is always very important, obviously, with not just maths, but learning anything. So you guys have been great. So keep at it. I hope to see you for the next 2 lessons and also for the next series that we'll be doing. So yeah, again, obviously we're not going to do the leaderboard today because we do that only once a week. So we're going to do the next one on Tuesday. So you guys have even more time to do activities and yeah, just make sure you get up in there on the app and do what you can. And so yeah, remember to go to, when you go to the app, pick a topic, functions and relationships, and then go to exponential functions, and then just make sure that you practice your sketching as you've done in these lessons, and also do the others just to prepare for the upcoming lessons. But otherwise, you guys, yes. Otherwise, you guys have been amazing. You guys have been great, and we'll see you. I think if Lee doesn't have anything to add, I think we can release you now and see you the next time. Bye, guys.
Absolutely. Bye, everybody. You're wonderful.
Bye.
See you on Tuesday. Okay, have a great weekend. Bye. Oh, man.